Hello there, Year 3, and welcome back to our comprehension lessons. So, I do hope you've had a nice half term and that you've been doing lots of reading. So now we're going to be moving back into our reading comprehension tasks. This is where I'll be reading through the text and then going through the answers to see how we can achieve full marks. The only difference being is that now for this term, we're going to be doing these video style lessons once a week because basically I was running out of text and I couldn't think of another way to do it. So this is going to be the best way to do it, is that you still get to see me like this every single week. So we're going to be doing set A this week, and then set B will be the next week. Then we'll be doing a new text after that until the end of term. So, right, going to go through the text, reading it through first of all as usual, then we're going to go through the answers and see how we can achieve full marks. So here we go. This is forces. There are many ways to explain what a force is. Perhaps the simplest way to think of a force is as something that can make an object move from one position to another. If an object is not staying still, there is, or was, a force that caused that movement. What is more, the object will continue to move until there is another force working in the opposite direction. Many forces are easy to spot. There are ones involving pushing, like when you are rolling a giant snowball to make the body of a snowman. There are also ones that involve pulling, such as a team of huskies with a sledge. In both cases, you can clearly see who or what is doing all the work. It depends on whether they are behind or in front of the object as it moves. There are, however, some forces that you cannot see at all. We don't mean things like the wind in the sails of a boat. That force is invisible because we can't see air, although we can still feel it. No, we're not talking about things like gravity, the force that pulls objects towards the centre of the earth. You can't see it, you can't feel it in the same way you can sense the brush of the breeze through your hair. However, you will certainly know about it if you've ever lost your grip on the monkey bars. Magnetism is another force you can only notice by the effects it has on certain materials. It's almost magic the way a magnet can pick up a nail, let alone the way it can still work through different materials. Have you ever seen iron fillings moving around in one piece of card because there is a magnet shifting underneath? If that's hard to wrap your head around, magnetism can be both a pushing and a pulling force at the same time. It all depends which end or pole another magnet is closest. We call these opposite ends north and south. The north pole will attract the south pole of another magnet, but repel the north. So, if you have a magnet and you know which way round the poles are, you can also work out which is the north end and which is the south of any other magnet, just by moving it close enough. The proof will be in the pudding, as they say, or rather, the pushing or the pulling. So there we go. Now we're going to read through the questions and see how we can achieve full marks for each one. So here we go, starting off with the vocabulary section. Question 1. Look at the first paragraph. Find and copy a word that means place. Look at the first paragraph. Find and copy a word that means place. So I'm going to look back at the first paragraph and I'm going to see if I can find and copy a word that means the same as place. So I'm going to read the first bit. There are many ways to explain what a force is. Perhaps the simplest way to think of a force is as something that can make an object move from one position to another. I'm looking for a word that means the same thing as place. Is going to be one position to another, isn't it? The word I'm looking for there is position. Position is the word I want, so that's what I'm going to write down, position. Right, question 2. Such as a team of huskies with a sledge. What are huskies? Such as a team of huskies with a sledge. What are huskies? This may be something you already know. You might already just know what a husky is. However, if you do look back through the text and see that bit where it's talking about such as a team of huskies with a sledge, there's actually a convenient picture just below that paragraph where you can actually see the two huskies pulling a sledge. So what are the huskies? They are dogs, okay, or a breed of dogs. They're a type of dogs, aren't they, okay? So dogs would get you the mark, okay? Right, question 3. The North Pole will attract the South Pole. Which group of words means the same as attract in this sentence? Tick 1. The North Pole will attract the South Pole. Which group of words means the same as attract in this sentence? Tick 1. So we've got pull towards it, push away from it, behave nicely to, or start a fight with. So, North Pole will attract the South Pole. Again, if I know my science and I know my magnets, I've got a North Pole and I've got a South Pole. Okay, I know that those two attract, so the North Pole, if it moves towards the south, should pull towards it. Okay, that is pull towards it for question 3. That's what it means to attract when we're talking about magnetism. If something attracts, it means they go together. If they repel, they push away. Okay, so there you go, if you didn't already know that. Right, retrieval, question 4. What does the text say that a force can do? What does the text say that a force can do? So again, it says, what does the text say? I need to find evidence from the text to back up my answer. I know this is a retrieval question, so I'm going to find something, pull it out, and use it. So, what does the text say a force can do? So, if I actually reread the beginning section, there are many ways to explain what a force is. Perhaps the simplest way to think of a force is something that can make an object move from one position to another. That is what a force can do, isn't it? It's something that can make an object move from one position to another. So that's literally what I've written. To make an object move from one position to another. That's something a force can do. Right, question 5. What was given as the example of a pushing force? What was given as the example of a pushing force? So look back through. A pushing force. Well, actually, there's a very convenient picture in the text. It literally is labelled pushing force. So what is the example that's given for a pushing force? It's right there in front of you. Couldn't be more clear. It is that person who's rolling a giant snowball, isn't it? And it actually then says to make a snowman. But yeah, it's that picture there. The pushing force is rolling a giant snowball. Okay? If you had rolling a snowball, I'd also give you that, but I just put a giant snowball because it is quite a big one. But yeah, rolling a snowball would be fine. Right, question 6. What are the two poles of a magnet called? What are the two poles of a magnet called? I did actually just tell you this one just a few seconds ago, but if we do want to get the evidence from the text there, it is that bit with the big horseshoe magnet, and it says right there, it all depends which end or pole another magnet is closest. We call these opposite ends north and south. North and south, that's what it says in the text. That's what I'm going to write down. They are called north and south, or the north and south poles, or the north pole and the south pole, anything like that. As long as you've got the north and south, then that's fine, you've got the mark. Right, inference, question 7. What does the text say is the main difference between pulling and pushing forces? What does the text say is the main difference between pulling and pushing forces? So again, I'm going to have a look through. It says, what does the text say? So I need to find some evidence in the text that backs up my point. What does the text say is the main difference between pulling and pushing forces? So I'm just going to see what we've got here. Yeah, just above the pushing and pulling forces pictures. It all depends on whether they are behind or in front of the object as it moves. That's what the text says, isn't it? It all depends on whether they are behind or in front of the object as it moves. I'm just going to check what I wrote down, see if I elaborated on that, or is that what I just put? I wrote, it all depends on whether they are behind or in front of the object as it moves. So there you go. That's basically the answer, isn't it? So yeah. Question 8. If we can't see magnetism, how do we know about it? If we can't see magnetism, how do we know about it? So just having a look at that magnetism section, I've got the big horseshoe magnet again. That's the big clue as to where I'm looking. So how do we know? Magnetism is another force you can only notice by the effects it has on certain materials. So I wrote, you can see its effects on other materials. You can see its effects on other materials. That's the answer, isn't it? Right, question 9. If that's hard to wrap your head around, which group of words best explains what this means? If that's hard to wrap your head around, which group of words best explains what this means? Tick 1. So if that's hard to wrap your head around, what does that mean? That is a saying, everybody. If wrap your head around that is a saying. So you might well know what it is already. You might have heard somebody else use that expression, to wrap your head around something. Okay? So basically, if you wrap your head around something, it's sort of a way of trying to help you to understand something. So it feels like your skull. If you're wearing a hat, it's not that easy to understand. Or if it makes you feel sad, well, it's basically what I just told you there. It's the if that's not easy to understand, okay? So it's basically saying, if that's not easy to understand, or if that's hard to wrap your head around, okay, to wrap your head around something is to understand something. So that's the answer for that one. Right, summarising, question number 10. Here are some summaries of different paragraphs in the text. number them from 1 to 4 to show the order in which they appear in the text. Here are some summaries of different paragraphs in the text. Number them from 1 to 4 to show the order in which they appear in the text. So we've got some forces are invisible. Magnetism is a force that only works on some materials. Forces can push or pull, or forces make things move. Well, we know that the magnetism stuff comes later, don't we? So we know that one is going to be towards the end, so it's likely that one's going to be 3 or 4. We also know that the pushing and pulling comes towards the start because we've got that picture at the start. So big clues here to sort of section these out. So the thing about the forces pushing and pulling, or making things move, that's going to be the first one, isn't it? So let's just double check through the text. So we're looking for forces, anything about the moving or pushing and pulling. For an object staying still, therefore it was, causing movement. So yeah, movement is there. That's the first one, isn't it? Making forces move. Forces make things move. That is the first one. Forces can push or pull. That's looking like it's coming next. Forces pushing and pulling. Yeah, involving pulling, such as a team of huskies with a sledge. And these involve pushing as well, like rolling a giant snowball. So yeah, that's going to be a second one, forces that can push or pull. Then we've got either invisible or magnetism. Next paragraph says, however, there are some forces you cannot see at all. That is going to be the same thing as invisible. That's your point 3. And the last one is the magnetism, working on other materials. Then it's the magnetism, another force only noticed by the effects. So there you go. The order should be 3, 4, 2, 1. 3, 4, 2, 1 is the order. Right, question 11. Predict. What would gravity do to your body if you ever lost your grip on the monkey bars? What would gravity do to your body if you ever lost your grip on the monkey bars? So, it did say something about that if you were on the monkey bars, didn't it? But again, you might well just know what would happen. So if you were on the monkey bars right now, okay, and you happen to lose your grip, so you're on the monkey bars and you can't quite reach the other one, what's going to happen to you? You're going to... That's right, you're going to fall down to the ground, aren't you? So you would fall down to the ground, or if you want to be more specific, gravity would pull you back down to the ground. Let me just see what it is I wrote there. What did I write? Gravity would pull you down to the ground, and I've also put the other answer there of you would fall down. So there you go. Right. Question 12. Compare. Using what the text says, describe one way in which magnetism is... We've got A, similar to other forces, or B, different to other forces, different from other forces, sorry. So using what the text says, describe one way in which magnetism is similar to other forces, or B, different from other forces. So how is it similar to other forces, and how is it different to other forces? So again, I'm looking for magnetism, so I'm going to find that section of magnetism. It's that bit at the bottom with the big horseshoe magnet. And I'm looking for some way they are similar, so let's have a look. Actually, if you look at the second paragraph there, it says there, if that's hard to wrap your head around, magnetism can be both a pushing and a pulling force. Okay, that's going to be a similarity, that they can be both pushing and pulling. That's how they are similar, but how are they different? So how are they different? Just having a look. It says there, at the beginning of that section, magnetism is another force you can only notice by the effects it has on certain materials. That is the difference, isn't it? That it can't be seen, okay, and it doesn't work on all materials, okay? We know it's only metallic objects, so that is going to be, like it can pick up a nail, but it can't, for example, move a wooden table. So there you go. Sorry, it can't be seen, and it doesn't work on all materials. But the similarity there is that it can be a pushing or a pulling force, depending on how you're moving that magnet. So there you go. Right, that is all of the questions for set A, so that brings us to the end of our comprehension for this week. So thank you very much, everybody, and remember that next week on Monday we'll be doing set B of exactly the same text. So tune into that one next week and we'll go through the questions and see how we can achieve full marks. So take care, keep up your reading, and I will see you next week.